Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to go through the effect of quadrant, right? So quadrant on converting to polar coordinate. Right, so I've got 4 different points here. This one we've already done before, where we are in quadrant 1. So in case you've forgotten, right, this is quadrant 1. Right, this, and that's quadrant 2. This is quadrant 3. And then this is quadrant 4. And so what I want to do is I want to talk about what happens when we convert to polar coordinates, right, from 1, 2, 3, and 4, and talk about what you have to be aware of when you do those conversions. So let's start off with this one here. All right, I'm going to do the exact same thing I did before. We're going to draw a little triangle here. Okay. And then I want to talk about what we're actually measuring in terms of theta, right? So if this is our triangle, right, this is the theta that we're measuring right here. So as always, right, we have the relationship of r is going to equal the square root of x squared plus y squared. Right, and that's going to be the same for all of these, right? All of these are going to have the exact same coordinates. And in fact, let me do this. All right, so we have 4 triangles. So our first triangle we're going to do is this one here. And so the theta that we get out of it, so this is going to be r, right? This is going to be r, this is going to be r, and this is going to be r. So hopefully just visually you can see that r is never going to change, right? It's the same distance. But what we are changing is what we're getting in terms of theta. So in this triangle, right, when it's in quadrant 2, theta is the measure from the negative x-axis to r. When we're in the first quadrant, which is the example we went through last time, right, theta, right, this is our theta here, which is exactly what we would expect it to be, right? When we're down in quadrant 3, right, this is our theta. This is our theta that we're getting. And in quadrant 4, right, in quadrant 4, right, this is the theta that we're given. And so what I want you to keep in mind here, and maybe I've muddied the waters a little bit too much, is that the thetas are going to change depending on what quadrant we're given. The theta that we're actually getting, right, is going to change depending on what quadrant we're given. And so we need to keep that in mind in terms of what theta we actually expect. So let's talk about quadrant 2. All right, so we have x squared, so minus y squared. So just finish calculating r, right? It's going to be the square root of 3 squared plus 2 squared is equal to the square root of 13, right? So this is going to be the same no matter what, right? This is always going to be the square root of 13. This doesn't change. What does change is theta. Right, so when we're in quadrant 1, right, theta is going to be equal to the arctan of y over x, right? That's what we did in the previous video. It makes perfect sense, right? This is the theta that we're measuring. This is the same theta that we want to get, okay? That makes sense. Let's talk about quadrant 2, though, because this is where things get a little bit different. Right, in quadrant 2, right, theta equals arctan of y over x, right? But in this case, right, our y or our x is negative. which means our angle is negative. All right, so let's just take a look. So in this, for our specific example here, right, 2, -3, right? We're -3, 2. So if we put on our calculator and we do 2, right, y over, and then we do 3, and then we click this button here to make it negative, right, our tangent is negative. So if we do the arc tangent, which is shift T, we get a negative angle. Right. So we get a negative angle. Well, that doesn't make a whole lot of sense. Well, what is this actually saying? Right, this angle that we're measuring here is saying the difference from here to here is negative. Right, saying this is negative 33 degrees. Right, but that's not what we actually want. Right, what we want is this measure here. Let me see, do I have any other colors I can use? Let's use yellow. Right, what we actually want, if you think about what we're looking for in polar coordinates, is this angle here. Right, so in quadrant 2, right, what we want is this angle here. Well, how do we get that? Well, that's 180 minus this piece here. But because theta in quadrant 2 is negative, we simply add 180 degrees, right? So for quadrant 2, what do? Theta is actually going to be equal to 180 degrees, or pi, plus arctan y over x, or plus. Right. So this is where, this is if we're talking about degrees, this is if we're talking about radians. So if we go ahead and do that, right, if we take our quadrant 2 and we add 180 degrees, we get 146.3, right, 146.3. So this would have a value of root 13 and 146.3 degrees. And does that make sense? This is 90, this is 180. Yeah, that seems pretty reasonable. So just to sort of reiterate over here, right, this one had a value of root 13 and a value of, if we remember back to our previous video, right, it was going to be 30, actually let's pull up our calculator just to make sure we get this right. It's going to be, if we subtract 180, it's going to be 33.7 degrees. All right. So let's talk about quadrant 3. What happens in quadrant 3? Well, right, again, still going to be a square root of 13, right? That hasn't changed. This is still going to be the square root of 13. Right, so this is going to be square root of 13. But what happens in this case if we take theta? Because the theta is the thing that's changing. Right, in this case, theta equals arctan of y over x. Right, but in this case, x and y are negative. I'm going to slide down just a little bit here. Right? So the angle is positive, but wrong. Right? The angle is positive, but wrong. Right? Because again, this quadrant 3, this is going to give us the same angle as quadrant 1 did, right? It's going to give us that 33.7 degrees, but that's clearly incorrect, right? We're down here in quadrant 3. So what do we do when we're in quadrant 3? We say that theta, actually, hold on. Before we do that, what is this actually measuring? Right, this is telling us that from this line right here to this line right here is 33.7 degrees. But what we want is we want this angle here, what we actually want is this. All the way around and then plus that. All right, so hopefully you can see that what we want is this angle plus 180 degrees. So we're going to actually do the exact same thing. We're going to do theta equals 180 degrees plus the arctan of y over x, or pi plus the arctan of y over x, right? So in this case, we added it because the angle was negative, which meant we went backwards a little bit. In this case, we're adding it because the angle is positive, and we're going to go forwards a little bit. Okay, so let's do our example here. Let's go here. So we will clear out everything we've done, and we will do negative. We'll do 2 negative divided by 3 negative. It's going to be that. Shift T to get the arctangent, 33.7. And now we're going to add to that 180 degrees, 213.7. All right, so in this case, we're going to get 213.7. So this is going to be, oops, I actually did that in the wrong color. It's going to be the square root of 13, and then 200, what did we say it was? It was 213.7. Right. So hopefully that makes sense. Let's do our final one, which is going to be what happens when we are in quadrant 4. Well, we're in quadrant 4, right? Again, r is going to be the same thing, right? We haven't changed our distance at all. We're still the same distance. So this is going to be the square root of 13. What about theta? Well, theta in this case, right, is going to be, again, as always, it's going to be the arctan of y over x. But in this case, y is negative. Right, y is negative, so the angle is negative. Right, y is negative, so the angle is negative. So we're essentially having the same problem we had up here in quadrant 2, where we ended up with a negative angle, and it's going to be the exact same thing, right? It's going to be that negative 33.7. Let's just go ahead and confirm, right? If we do, so in this case, our x is positive and our y is negative. So it's going to be, let's clear out what we've done before. 2, click the little negative here, divided by 3, negative 0.66 repeating. So this is the negative tangent. And hit Shift T to do the arctangent. Okay, so we got the negative 33.7 degrees. So what is that telling us? Well, that's telling us that the distance from here, that's telling us the distance from here to here, right, is 33.7, right? That's what the negative is telling us. So we're going backwards, right? We're going against the flow, right? Just like here, we were going against the flow. We're going against the flow, 33.7 degrees. When what we really want, right, is we want, sorry, I'm speeding up my curls here. What we really want is this angle right here. This is what the theta that we would want. Well, hopefully you can see here that this theta is going to be 360 degrees minus what we got. But again, because it's negative, the angle is negative, we add them. So in this case, right, this is going to be theta is going to be equal to 360 degrees plus the arctan of y over x. Or you could say that it's 2 pi plus the arctan of y over x. So hopefully that makes sense. Hopefully the intuition of it makes sense. If you have any questions, please reach out. Thank you.